quick video on just another redo of will a reaction occur, and we're talking about replacement reactions, single replacement reactions, and the two kinds are the hydrogen replacement and the metal replacement. So if we look at the metal replacement first, and we take the example aluminum, and since it's written like this, it's got to be solid aluminum, is added to a solution of silver nitrate. So that means our nitrate is going to be a spectator, so we don't even need to worry about it. And so the question is this going to happen? Well, if it does, what would happen? The aluminum would become an ion, and it would become a +3 ion, and the silver would become the metal. It would have to be reduced. Okay, so no, this isn't balanced, but it would. But the question is, will it happen? Is aluminum an active enough metal to replace silver? So the battle is, who gets the electrons? That's kind of your question. So who gets the electrons? And so whoever gets the electrons is going to be the one that is reduced, and the reduced species is going to be in this case, the elemental metal. So let's go look at the table, because that's the only way we'll know. So go find aluminum and go find silver. So shopping, silver. Okay, so here's silver, and here is aluminum. Okay, so aluminum is a -166, and the standard reduction potential for silver is 0.80. So this one is higher, therefore it is going to get the electrons. So if it is not, that means if it gets electrons, it's going to be reduced. So if it's not already in its elemental form, it's going to get there. So this gets the electrons and gets reduced. So can silver take electrons on? Yes, it can be reduced because it's in the ion form. Therefore, this reaction will take place. So, but you would have to balance it, right? Because if you have, this is giving off 3 electrons, then you have to have 3 silvers to take that electron, to take on all those electrons. Then, if you had, so let's say instead of aluminum, let's say we have copper. So, we don't want copper ion. We're not there yet. We want solid copper. So will copper replace that silver in solution? So because this is in solution, then we know we have the ion. So go find, we already know where the silver is. Where is copper? So here's copper. So this is a 0.15. Silver's still higher, so it's going to get the electrons if it's not already reduced, and it's not, so it'll take on these electrons. So silver gets reduced to the elemental form, and copper is oxidized. So of course we would have to have 2 of those. Okay, so now let's go try a different one. So let's say, how about gold? Gold is added to silver nitrate. Well, here's silver and here's gold. So 0.15 versus 0.8. Gold has to take on the electrons. So it's going to end up being in the reduced form, and that would be in the solid form. Well, if I look at it over here, it already is. So it can't be reduced anymore. Therefore, this reaction does not happen. So let's find another one. What if we put aluminum, or let's just say we'll take iron. We'll say we have iron 3 plus right here. So if we put that in solution with copper, or we could even do the ions. If we put that in solution with copper 2, who is going to be reduced? Well, you've got to compare this number and this number. The larger the reduction potential, that's the one that takes the electrons and gets reduced. So in this case, that would be this iron being reduced to 2 plus. And then the copper would be oxidized, except this one isn't a real reaction. But anyway, that's how you would do it. So you can say whether or not it would happen. But copper is not really going to become a plus 3, so that's kind of a moot point. You wouldn't be given that reaction. But if you just play it that way and you look at the numbers to see who has to keep the electrons, if the species can be reduced, it's going to be reduced. So let's look at halogen replacement. It's the same thing. So halogen replacement, and we have to find the hydrogen. So this would be like hydrogen from an acid. So if you have an acid in the solution, it's going to look like this. So we would check it from here in that reduced state, that ionized state, and notice that it is here as 0 for comparison, but we can still determine whether or not a reaction is going to happen. So chlorine's going to be a spectator, so we're just going to leave it out. So let's say we added a metal like, let's see, let's say we add zinc, solid zinc metal to the acid. You already should know this is going to make a reaction. So let's just prove it numerically with something you already know. So zinc, the standard reduction potential for zinc is a negative 0.76. And for the hydrogen ion, it is 0. 0 is greater than 0.76. Hydrogen gets the electrons. So it can take on electrons because it is in this ionized state. So it is going to become H2, and the zinc will become an ion. Okay, so we'd have to have 2 of those. So now let's see if can 10(4), if we put hydrogen with 10 4 plus, let's see if it, well, let's not do that. Let's put it with 10 metal. But we could put it with 10 metal and it would still be the same thing. So let's see, that would be our reaction. So let's see, we're just going to find 10 where it is in its reduced form. So we're looking at this. And so that's a negative 0.14 that I just crossed out. And let's see, we've got hydrogen ions, and they're still at 0. So yes, hydrogen will be replaced. So, because it's got to take on the electrons. It can, because it's in the ion form, so it's going to be H2, and then you would have SN2 plus or 4 plus, whichever way it would go, but you wouldn't know that, so either one would be correct. So, looking at these values and deciding who has to take on the electrons is a way to determine whether or not the reaction takes place. So let's look at the hydrogen ion, and let's say silver plus silver. So silver is 0.80, silver's 0.80, hydrogen is 0. So silver has to take on the electrons. Well, can solid silver take on electrons and become a negative ion? No. So no reaction. It's already in its elemental state, so it's not going to take on electrons. It can't do that. So there's no reaction. So if you get it like that, great. There's another way that you can think about it, and that would be to think of this as an upside down. It is an upside down activity table or an activity series for metals. So the rule says that the more active metal can replace a less active metal. So our most active metals are found here at the bottom of this table. These are our most active metals. So lithium is the most reactive of these metals. And so we're going to find that if the most reactive or the more reactive metal can replace a less reactive metal, or the hydrogen or the water, it can kick hydrogen off of water and make a base, or it can kick hydrogen off of an acid. This is your acid business. Can replace a less active metal or hydrogen. So, if you think about it this way, you just flip it around. This would be the most active. So everything above it in this reduction table is going to be less active. So if you're looking at the reaction between, let's see, magnesium plus copper 2 ions, find magnesium. You can just find it in this column. So magnesium and copper. So where is copper? Okay, so magnesium is here. It is more reactive than copper of any form, and so it will replace it. This reaction will happen. So magnesium can replace copper ions in solution. Can copper replace magnesium ions in solution? Well, here's magnesium, and copper is up here, so it won't be able to replace something below it. So magnesium is more active than the copper, so this will not happen. It can't replace it. Okay, so that's another way to look at it, is if you want to think of anything above the metal here being able it could, anything down here can kick off anything up here. All right, and then the only other kind that we had was the halogens. And the halogens are, you can bump Big Brother, so you bump Big Brother, triple B's for halogens. So chlorine can replace, so you would have something like Cl2 can replace, you're looking at what element, what halogen can replace a halide. So this can replace any, it can bump Big Brother, so it can replace bromine or iodine, but it cannot replace fluorine. So if you had Cl2 plus HF, well, this is ionized, and so chlorine cannot come in and replace that, so that would be a no reaction. But if it were chlorine plus HI, then chlorine can replace this, and the iodine would become elemental, and the chlorine would go into the solution, and it would become the ion, and so it would look like HCl minus. And this would have looked like H plus. If you're ionizing in it, it's going to happen. Because this is soluble, right? So Cl2. Now, the so full out, this would be I2 plus H plus, but this is a spectator, so we'll have to get rid of that. So it would look like Cl2 plus I minus, but I'm going to have two of these, and I'll end up with two chlorines plus I2. So my charge minus 2, atoms balance, I'm balanced. So on some of the reactions you have to show the whole half reaction. On some of them you do not have to show the half reaction. You just show the final balanced NIE. Okay. I hope this helps, and I just don't want you to confuse something like lead nitrate is mixed with potassium iodide, and you try to start doing some redox reaction with it. Alright? Okay. Well, if you got this, then you are good to go. I'll see you in the morning. Hasta la vista, baby.